right, let's put those phones away, Angel. And go ahead and take 30 seconds, share your summary statement with your neighbor, and make sure that they have one that's adequate, that's at least 1 to 2 complete sentences. So go ahead and share, and then we'll have a volunteer share with the class their summary statement. All right, who feels confident for an AMRO award that they can share their summary sentence? I think they got a good one. Yeah, Angel in the back.
The purpose talks about how soil needs certain permeability to grow.
Yes, very good. We are going to be talking about permeability once again. Permeability refers to how fast what flows through the soil?
The liquid.
One more time, how fast what flows through the soil?
Water.
Water, very good. So we are actually going to be testing the permeability of 4 different types of soil type materials. So we'll go ahead and look at our packet. Let's turn to page 1. Everybody point at part 1 on page 1 so we know we're on the same page. So first thing we're going to do is we have 4 different samples of soils and soil material. We have a gravel sample, a sand sample, a sand-clay sample, as well as a loam. And what's a loam again?
Sand, silt, and clay mixed together.
Yes, very good. So it's like a sand, silt, and clay soil that has all different particles mixed together. Now quickly flip to page 3 and point at that table 1 on page 3. Wait for everybody to get there. All right, so for part 1 of this activity, what we're going to be doing is we're going to be filling out column 1 of this table, physical characteristics, as well as column 2, which is permeability predictions. Which columns are we filling out? Numbers 1 and 2. Numbers 1 and 2. Very good. So for physical characteristics, what we're going to be doing is we have these little tiny pan magnifying glasses that are mini and cute and adorable. So what we're going to do is we're just going to look at each sample with these magnifying glasses, kind of assess the pore space and kind of the size and shape of those particles. Are there large pore spaces, small pore spaces? Can you tell each individual particle apart from each other, or can you not really distinguish between particles because they're so small even with this magnifying glass? So there's probably 2 that you'll be able to see each distinguished particle, whereas maybe 2 of them that have those smaller particles, you're not going to be able to distinguish one particle from another, and it's going to be really hard to see those tiny pore spaces. So from that, we'll write those physical characteristics that we noticed with our magnifying glass in column 1. What column will we write those characteristics?
1.
Column 1. Followed by that, we're going to make a permeability prediction, because we know that materials that have a large pore space will have what? A high or a low permeability?
High. Low.
High? Yeah. So remember that we know that when there's larger pore spaces, materials are probably going to have a higher permeability, meaning the water is going to pass through those particles at a much higher rate. So we know that if there's high pore space, there's going to be what? High or low permeability?
Lower.
Remember? More pore space, high or low permeability?
High. No. Low.
Okay, so remember, pore space refers to the space between the soil particles. Larger particles, gonna have that larger pore space between them. So we think if there's more space, is the water gonna pass through it slower or faster? Everybody.
Faster.
Everybody, slower or faster?
Faster.
Faster again. So that refers to a higher permeability rate. So just remember, if it looks like in your observations that there's a lot more pore space, larger pore spaces, then it's probably going to have that higher permeability rate. That water is going to pass through those particles faster rather than slower. So after we write down those physical characteristics in column 1, which is just observing how big are the particles, how big are the pore spaces with our magnifying glass, in column 2, we're going to make a prediction of which one, from 1 being, I believe, 1 being the least permeable to 4 being the most permeable. So 1 would be the one where we think the water is going to pass through it the slowest, 4 being the one we think the water will pass through the fastest. You guys are going to make a prediction of the 4 samples of which do you think is going to go fast versus low, numbering them 1 through 4. What will we number them through? 1 through what?
4.
4. Very good. In which column? 1 or 2?
1.
We're going to make the permeability prediction in which column? 1 or 2?
2.
2. Let's go through that again. Remember physical characteristics, that's looking at the magnifying glass, assessing the pore space, assessing the particle size. That's going to go in column 1 or 2?
1.
Everybody, 1 or 2?
1.
1, very good. Followed by making that permeability prediction, how fast we think it's going to go through those materials in which column? 1 or 2?
2.
Everybody, 1 or 2?
2.
2, very good. So that's part 1. We're filling out columns 1 and 2, just looking at the physical characteristics with the magnifying glass and making a prediction 1 through 4 of which ones we think will have a higher permeability rate versus a lower permeability rate. After we do that, we'll move on to part 2. Part 2 is going to help us fill out columns 3 through 5. Which columns will we fill out for part 2?
3 through 5.
Which columns?
3 through 5.
Very good. 3 through 5. So what's going to happen with that is we're going to be working in groups once again. For that, with each sample, we are going to have one of these profile tubes, or we kind of have profile cups. Now there is a hole in the bottom of these profile tubes. So one partner is going to plug the hole with their finger. Another partner is going to take each individual sample, so there'll be 1 sample per cup. Each group has 4 samples and 4 cups. Each group's going to have how many samples?
4.
How many samples?
4.
Followed by how many cups?
4.
4, very good. So 1 sample per cup. One partner is going to plug the bottom of the hole on that cup, pour in your sample, so it's pretty even out. So after that, we will have a beaker filled with 50 milliliters of water. How many milliliters of water?
50.
50, very good. So we're going to, with one of our partners plugging the hole in the bottom of the profile tube, we're going to pour in our 50 milliliters of water so that we're plugging it so none of the water will drip out, and we'll have our gravel for this example as well as 50 milliliters of water. After we've poured it in, again, we're still plugging it so none of that water seeps out. Another group member is going to have a timer. So when they have that timer ready to go, what you'll do over the now empty beaker is hold that profile tube over the beaker, and then as soon as you remove your finger and the water starts draining, your other partner is going to start the timer. And then you're going to time how long it takes for the water to completely drain out of that sample and back into the beaker. So water will be draining back into the beaker. After that, you are going to calculate on your sheet in column 3 how long it took for that 50 milliliters of water to pass through that sample. So what are we writing in column 3?
The time that it took.
The time it takes to drain through that sample. Very good. Followed by, after the water is done draining, we are going to look at our beaker and assess how much water was collected. Because, spoiler alert, some of the water is not going to completely drain through your sample. Some of it is going to be retained within that soil. So you might have 40 milliliters of water after pouring 50 milliliters into your sample. So if you had 50 milliliters of water to start with, and then 40 milliliters was drained into your beaker, how many milliliters of water would be retained in your soil?
10.
10, exactly. So that water is pouring through, you start with 50. If you get 40 at the end left in your beaker, that's going to be how much water is retained within that soil sample. So that's what you will write in column 5. And if you're confused by that equation, it's on step number 8 of part 2 of this lab. So to find the retained water sample, it's the amount of water we start with, which is how many milliliters?
50.
How many milliliters?
50.
Everybody, how many milliliters?
50.
50, yes. So we're starting with 50 and we're subtracting 50 from how much water ends up in our beaker after the sample has drained through. So we're gonna do that and repeat it with each of our 4 samples. So again, columns 1 and 2, that's gonna be part 1. We're gonna look at our samples with our little magnifying glasses, and we're gonna assess kind of the pore size and make a prediction of the permeability rate. Followed by that, we are going to place each of our samples into our cups, and then we are going to plug the bottom of the hole, pour our 50 milliliters of water in, place back over that same beaker, and time to see how long it will take to drain all of that water. The time it takes to drain the water, which column are we going to put that in? Everybody look at the chart. Which column is going to be the filtration? Number 3, yeah. Show me on your fingers. Once again, where are we going to put the time of filtration? Which column? Why do I only see 3 people's fingers up? All right, yes, we're going to put that in column 3. Followed by, which column are we going to put the water that is collected in the beaker after it's drained? Show me on your fingers. Ava, which column? Right, so we're going to put that in column number 4. Followed by, once we calculate how much soil was retained within that sample, in column number 5. So we'll go ahead, I know this is a little confusing, we'll break it up into parts. So let's take 5 minutes when we get into our groups. We'll work on part 1. So we'll hand you out your 4 soil samples and your little magnifying glass. After those 5 minutes, we'll reconvene and we'll talk about how to, once again, do that filtration through our cups. Let's go ahead. We're gonna have 5 groups. So I'll have group 1 be this group, group 2 be that 4 in the back, group 3 will be tables 1 and 2, group 4, tables 3 and 4, finally group 5 will be tables 5 and 6. All right, so we're just do part 1 for now. When I say go, select one person to come up, grab your 4 soil samples and a little magnifying glass. We'll take 5 minutes, again, to just fill out columns 1 and 2. Which columns are we filling out?
1 and 2.
Very good, columns 1 and 2. Take the magnifying glass, look at our particle sizes, assess how big we think the particles are and kind of what the pore space is, and figure out that permeability prediction. What can I clarify? Okay, when I say go, get into those groups. I'll set a timer for 5 minutes. Once we complete that, we'll reconvene and start working on part 2, okay? All right, on your mark, get set, go.
Yeah.
So we're just grabbing, no, we're not grabbing those yet. We're just grabbing our samples and our magnifying glass. So we're just grabbing our 4 samples and our magnifying glass. Did a group grab 2? There should only be. Oh, so you guys are supposed to work together. So go ahead and hand those 4 samples over to this team, and then you guys will turn around and work. Okay? Good. Sorry about that. So again, what are we doing? Not yet. No, was this any water? Remember, okay, so let's do part 1. Yeah, very good. So you're going to take a little magnifying glass, look at each of your samples, and kind of write down the characteristics you see, small and large particles. Which
Yeah, like.
And then make prediction, which one do you think is gonna have the highest versus the lowest permeability? Yeah, I'm following 1 and 2. Okay, so go ahead, look at all 3 or all 4 of those samples, pick where mine come left, make sure everybody gets a chance. I'll make those predictions, okay? Leah, you can Right? Okay, focus in, get it done. Alright, start the timer. Again, we'll take 5 minutes. Which one's that one? So you're making a prediction, so if you look at the instructions that kind of explain, so you're just marking 1 through 4, 1 being you think the one that's gonna have the lowest permeability, and 4 being the one you think will have the highest permeability. So which one will be the one you think the water will go through the slowest, or will be the one the water will go through the fastest? Yeah. But even this, you just want 1, 2, 3, 4, or like, just put your number. 1 being the highest? 4 being Got it? Let me answer that question.
And then on 4, that one's gonna have like.
Which one do you think?
Look at it.
Looking over here. So you guys have an L9 class this time. I'm just gonna write some like physical characteristics in here, like what does it look like, big particle, small particle, big space, little space. And then followed by like 1 through 4 on here, with 4 being what, high or low? Yeah. So predict, 1 would be the water was going through the most, and the water was the least being number 4. So you just rank them 1 through 4 of what you think their permeability is gonna be like. Good, want to hear any question? Yeah. Yeah, so remember, that's very good. Remember we talked about how they were usually getting the higher. They got more space in particles, while you were going to the faster gas. Okay, so you're just taking predictions. You're looking at it with the same, like the gravel. Look like there's a lot of space in those.
I think I went in your dirt. Let me get that. Let me get that from you.
Fast, yeah. Whereas with like the sand clay, can you even tell you one part from another? And you can really see so what you're doing is you're just writing down the characteristics of what you see, and then there's information 1 through 4. You'll write the numbers like, I think 1 will be the highest permeability and 4 will be the lowest. So 1 will be 4 or whatever order you think. Make sense? Okay, what are you okay? So for part 1, we're just working on the what it looks like.